morning, faithful students. Now we are going to learn the Laplace transform of a derivative of a function. So we take the Laplace transform of f prime. And as we know with the formula for Laplace transforms, that is the integral from 0 to infinity of e to the negative st times f prime of t dt. And now if we go back to our handy-dandy integration by parts, we can assign u and v to figure out what this is actually equivalent to. So if we set u equals e to the negative st and v to be f of t, because that's a simple integration from the derivative v prime, which is f prime of t. I think you can all probably follow that logic. So then we derive u to get u prime as negative s times e to the negative st. So now we go back to our integration by parts. So we have currently written the integral of uv prime. And so we know that this is equivalent to u times v, or e to the negative st, times f of t, which is v. And this will all be evaluated from 0 to infinity, eventually. And then subtract from that the integral from 0 to infinity of u prime v, which is, in this case, minus s e to the minus st times f of t dt. So now we can simplify this a little bit. We'll keep our uv term as a uv term, not evaluated yet. So e to the negative st, f of t, from 0 to infinity. Plus, and then s is a constant, and it's a negative with a subtraction. So that becomes positive s outside of the integral. From 0 to infinity of e to the negative st times f of t dt. You should recognize that everything, including and after the integral, is the Laplace transform of f of t. So that's just equivalent to s times the Laplace transform of f of t. So now let's evaluate our first part, the uv part. So when you evaluate it at infinity, we can assume that e to the negative st goes to 0 faster than f of t goes to infinity. So we can assume that this then goes to 0. And then when you evaluate it at 0, e to the 0 is just 1. So you get 1 times f of 0. So then you're left with 0 minus f of 0 plus the s times the Laplace transform of f of t. So we can rearrange this and make it look prettier and say that the Laplace transform of f prime of t is equal to s times the Laplace transform of f of t minus f of 0. This is a pretty powerful tool. Now let's look at the next case. So let's say we want to take the Laplace transform of the second derivative of f as a function of t. So we know that the derivative, this would be equal to that function times the derivative of f double prime, which is just f prime. So that becomes s times the Laplace transform of f prime of t minus f prime of 0. And then, to get it in terms of the Laplace transform of f of t, we take s times and then substitute what we just learned the derivative, or the Laplace transform of f prime of t is. So we have s times Laplace transform of f of t minus f of 0, close parentheses, minus f prime of 0 would be the Laplace transform of the second derivative. So distributing the s's, we get the Laplace transform of the second derivative of f of t is s squared times the Laplace transform of f of t minus s times f of 0 minus f naught of 0. So this is really a really handy thing. It is turning derivatives essentially into multiplication. And who would not prefer to do algebra or arithmetic over calculus? Someone probably just said, I would, and then you can continue to do so. The rest of us will use Laplace transforms. We'll see you in the next video.